Hello to everybody and welcome to today's session. So today we will have feature engineering. Okay, the topic for today is feature engineering. So along with explanation, we will see some coding as well. Again, I will be working on Jupyter notebook. Let me get into the folder. Okay, so today's session will be dedicated to feature engineering. Feature engineering as such has got quite a spread out breadth, but I will introduce you to some of the popular techniques. But before we begin with the techniques, let us see what feature engineering is all about. So when we say features, we have already used this term several times before, right? In our previous sessions.
Yes, ma'am.
Can you describe what features are?
Features are generally columns. Like feature selection we had in the random forest, where we selected the column, columns, which were the significance.
Yeah, most of the time we have our data arranged in a tabular format, meaning in rows and columns, usually. That is our preferred arrangement of data. So in those columns, you have some input variables listed along the columns, right? Those input variables are your feature variables. So feature engineering engineers those data available in those input variables. So the basic aim of performing feature engineering is to improve the performance of whatever the model you are going to build in the future. So when we talk of feature engineering, we are basically talking about certain tools that will help us achieve this target of improving the performance.
Ma'am, is this applicable for both types of models like statistical and machine learning? Yeah, only applicable for machine learning.
Yeah, in broader aspect here in this session, we'll be talking about machine learning. But machine learning do include statistical models, right?
Right.
We actually work on statistical models, specially defined for machine learning domain.
Okay. Okay.
It is all overlapped.
Yes, ma'am.
So let us start with, let me tell you some of the popular feature engineering techniques first. Let's see. It's already there. I hope it is clear what feature engineering is, right? The basic aim is to transform your input variables. Whatever the input variables you have to transform those variables such that it becomes more meaningful. So that when you prepare model for yourself, it will give you much better accuracy. That's the main target. That's the main aim. So some of the popular techniques would be, one of them though we have seen already in different aspects, that is imputation, if you remember. First one is imputation. Next is with respect to outliers. Outliers also we have discussed. Then we have some transformations. One of the popular form is log transform. Next comes binning. Then comes one hot encoding. This also we have encountered. We have many more, but we will see 3-4 of them. Another is feature split. So these are few popular techniques that help you deal with feature engineering. Okay. Okay. Imputation. Do you remember what imputation was or is?
Imputation means you are talking about the missing value imputation, or how it is, no? Missing value imputation.
Yes. When we talk about imputation, earlier we talked about imputation with regards to missing values. If some of your input variables or the feature variables appear with some missing values, you replace those missing values with some meaningful values, right? Like mean,
Yes,
median, or mode, depending upon the nature of the variable. If the variable is numerical, you will use mean or median. And if the feature or the input variable is categorical, you will use the mode of the data, right?
Mode. Right.
So imputation there was with regards to the missing values. Here imputation is with respect to whatever values you still have. We won't be dealing with missing values, but we will be dealing with replacing the values that we already have in the table. Somehow if some value appears incorrect, so you will replace that with some sensibly correct values. Okay, so here imputation is with this meaning. So we will see imputation. Let's first encounter these outliers. It will make the picture more clear. So when we say outliers, where do I see? Just give me a minute. Somebody is asking for approval. How do I see? Okay, fine. Done. Okay. So let us deal with outliers first. So when we talk of outliers, we are actually talking about those data.
Sorry to interrupt, madam. People are waiting in your approve.
Yes, sir. I have approved. I have approved,
okay,
sir.
Thank you, madam. Thank you, madam.
Yes. So when we talk of outliers means we are basically talking about those data values which seem to be too far away from other values in the column. Okay, so those will be called outliers. Values which look very different from the rest of the data. This means the outliers may be those numbers which are either very large compared to other data or very small compared to the data that you have. Okay.
No, abnormal in distance. Abnormal in distance from the data points.
Yes, meaning very large, very far. those data will be
Yes, ma'am.
far away from the data that you have, other data that you have. So either very large or it will be some very small values with respect to all the other values in the data. That is outliers. So the first big issue becomes how to detect outliers. You can deal with outliers only when you will be able to detect it, right? If you have a small number of data, so you can just look at the data and tell which one is the outliers, which one are the outliers. But if you have large number of data and you have to think of some way to deal with them. So we do have different methods to first visualize them or to find them. So we can categorize them into two. Either you can graphically visualize and check whether you have variables or not, or outliers or not. Okay, then that will be the first way. Second way could be to statistically find out whether your data have outliers or not. These are the two approaches. Okay, let us look at how to visually look at the outliers. Sorry. Now the simplest one is to have the box plot. Now, so as to have the box plot, let us get some data. Suppose let us call it X. Let us have one array, a simple array. Suppose let us call these to be our data. This is your array. We have already seen how outliers affect mean, median, and mode, right? Do you remember which one is the worst affected because of outliers?
201, ma'am.
Mean value.
Mean value, yes. Who said mean value? Mean is the most worstly affected central tendency value. That's why normally for imputation, mean is not preferred. If you have categorical value or somehow if you have to deal with such data, so you mostly go for median if it is numerical, else mode if it is categorical. Now here for this case itself, you can find out. Let us suppose do it. For our data, mean is this. Median is this one. Okay. Mode to leave it because I have made the frequency one for every data value, right? Let's suppose just look at this mean and median value. And we have one modified X array, suppose. So without outliers. Can you see? Without outlier, the mean is 12, right? Because of that outlier value of 201. 201 is the outlier. Can you identify? Rest of the other values are 5, 10, 16, 12, 14, 18, 9, right? 200 is far, far away from these values. So visually, just by looking at this array, we can say 201 is the outlier. Now, because of the presence of this outlier, the mean has shifted from 12 to almost 36. And median, there is not much effect, right? Earlier it was 12, now it is 13, just 1 unit shift. So mean gets affected very badly because of outliers. Now our thing is to visualize the outlier, right? So let us import our library. We will use Boxplot. Data is X, right? So if you just take a look at the Boxplot, just change the orientation. If you will just look at the box plot, you will see all the 5 number summary for the data is within this range. Only this value of 201 is far, far away. So if your data have outlier, you will have box plot of this form. Okay. That is how Boxplot helps you visualize outliers. Fine. Let us have a look at Boxplot of Y. The data which does not have the outlier. Let's see how does it look like this way. Can you see the difference? A Y array, all the data are consistent, right? There is no outlier. So all the 5 number summary is within the range. If your data contains outliers, you will have data points outside the range. Okay, this way helps you visualize the outliers in your data. Fine. Clear up to this? So this is visualization, which calls for manual interaction, right? But somehow we have to teach our machine how to detect outliers. So you'll have to have some statistics introduced here. So statistically, how we detect or define outliers is by using this. We have already seen this term before, z-score. Okay. What is this z-score? Z-score standardizes your data. How? Suppose you have this data X with you. You will subtract mean from it and then divide it by the standard deviation. all X values get transformed into Z. All these Z values are the scores, Z scores for the data X, okay? Data within X. So to statistically define outliers, we will be using this relation between X and Z, okay? Now, how to use, is it possible to have? Okay. Zoom, do we have any option of whiteboard? Anybody knows? Any idea?
I guess you have to use OneNote in that case.
No, if I need to draw something, is it possible to do it on screen? Is it visible? Is this one?
Yes,
Yeah,
ma'am.
yeah.
See, Z score. Wait. How Z scores will help you to locate the outliers. See, where the Z score lies on the normal distribution, you will get the idea from this figure. This figure graphically shows you how Z score is distributed, okay? Z score of value 0 is here at the center of the distribution. Somewhere here will be Z score of value 1, Z score of value 2. Somewhere here, Z score of value 3. Similarly, on the other side, -1, -2. We're here, -3. If the Z score lies here or here, you will treat the corresponding data as outliers, okay? This is actually this distance from here to here is said to be 3 standard deviations away from the mean, okay? No. This. Similarly, this one. Yeah. If your Z score is either beyond 3 or -3, you will consider those values to be outliers, okay? These two locations. That is how you will use Z score to detect the outliers. Whatever the data you have, you will find the corresponding Z values, okay? Z scores. And then you will check in loop all the values. Those values which are within 3n - 3, those are significant values for your modeling. Whatever the values lies outside this interval, those are your outliers. Okay. Now let us try to use this very idea and check how it works. Suppose for our data, this X, we wish to check for the outlier using this approach. How do we proceed? We have to find the z-score, right? So we can have that formula. We have to check for every data value, right? That means we will be needing a for loop. So we will loop for I in, our data is in X, right? For I in X, for every I in X, we need to find the Z values. So we will have I is our data minus mean. I'm just following that relation. Mean of I divided by its standard deviation, right? Up to this will give you the Z values. Now the condition is if this Z values lies outside these intervals, no? If it is greater than 3 or less than -3, we have to discard it. So how do we write it? That means if Z or the absolute value of Z, we can say na, if absolute value of Z is greater than 3, we can discard it, or that will be considered as the outliers. So let us make an empty array for outliers where we'll append the values. So let's have this one where we can append the outlier values. So we'll append this Z values. Sorry, you need I, right? Not Z. Up to this is clear. We are trying to find the outlier in our data X. Okay, X has the data values and you are looping through the values in X. So for every I in X, you are finding the corresponding Z values. Z value is mean subtracted from the data divided by the standard deviation. Now, if this Z score is greater than 3 or less than -3, that means the absolute value is greater than 3. Those will be considered outliers. So the corresponding I is your outlier. Okay. Let's check. No, it is still empty. What is missing?
Ma'am, in Z, I think it is I minus NP dot mean of X. Ma'am, you have written
Oh,
NP dot
sorry.
mean of I.
Yes, yes. Thanks. Thank you. Thank you. Good, good. No, it still says 0y. X is the... Did I change X somewhere? No. This is our X. It has this outlier 201. What happened? Why is it null? Why is it null? For every I in our X, I'm looping through these values. We are calculating Z, right? I minus, no, it will be I, na? I'm considering I. This is data, mean of the, mean of X. Oh, it's fine. It has to be mean of X now. Why is it returning null? Anybody? Can anybody detect where I'm mistaken?
Ma'am, is there any difference between NP or in the list?
What?
Ma'am, is there any difference between NP array, NumPy array, and a simple list? I think it will be issued. I think so.
I'm not getting. Repeat again. Repeat.
I think you have considered X as NP NumPy array. If you consider X as a list only, I think that then this code will work. I think.
Ma'am,
But
we
I
don't
don't
want
know.
to, yeah, wait one second. We don't want that NP, ma'am, actually. We already converted to NumPy array, so it's already in the format of array. So we don't want to use that NP. We just exclude that NP, ma'am, it will work.
You mean to say I don't have to use NP here?
Yes, ma'am. We already converted that to an NumPy array. Yeah, now here also exclude that NP. Yeah, now check it.
See, you have to tell, na, mean from which.
Can you import statistics and find mean using it for
Yeah, statistics
X?
also you can use, but NumPy also
Maybe
provides methods, na?
Yes, ma'am. But can we check what is the NP of STD here? Like maybe that's something wrong.
Is it? No, it is calculating, na? NP.std.
Ma'am, can you print Z?
Yes, we can.
Ma'am, can you print Z?
Yes, let me see. Okay, it is printing, but element by element. I am not just
Ma'am,
saving it.
ma'am, in X, you have considered NP array, NumPy array. If you consider a list, only a list, not NumPy array, it will work. This code will work.
Wait.
To
To
go
say
above. Yes, ma'am. Copy all this.
why?
Now, ma'am, try.
No, it's still an array, na? Oh. Somewhere some simple thing is missing. Okay, we'll look at it again. But for the time being, this is how you will find the outliers. Huh? You will find the z-scores. Those z-scores which lie outside this bound are your outliers. Okay. There is some simple mistake I'm unable to figure out. So it should give you the value of 201 here. Okay. Since 201 is visually your outliers. Huh? It's clearly seen. So once you detect your outliers, there are several ways to treat these outliers. How do you treat the outliers? That becomes your next step. If you can figure out what is wrong here, do let me know, okay? Somehow I'm missing some simple things. If somebody spots, do let me know. Let me proceed ahead with the treatment of outliers. Now, even before reaching this treatment of outliers, we should have a little discussion about why we are even discussing outliers. Huh? Why should a data contain outliers? Any idea? Why should a data contain outliers?
Mean and the STD is not defined. If mean and STD is not defined, we need to define that before we get into loop.
Is it like that?
Yes, ma'am. Mean equal to, we can say that NP dot mean X. Yeah.
It should work this way. I don't know what is the problem here. No, it is still returning null. Leave it. Let's see how to treat these outliers. How to treat the odd one out. That is the next big question. Okay. So there are several ways to treat it. One of them is to just remove it. You can just remove it. You can trim the data, or you can remove that particular data, which is your outlier. Second can be a proper imputation. You can replace that outlier value with some meaningful value. That means you can impute. So second way is to impute the data with some mean, median, or mode. You'll have to properly look at the data and then you will do the replacement. Next is you can use quantized values. You can either floor and or cap the outlier value. The outliers.
Ma'am,
Yes.
it is not returning outlier because in outlier the formula is I minus mean standard deviation. So here I is 36 something and deviation is 62. So the result of this would be less than 3.
Yes, less than 3, right? Negative. That is why we have used.
Here, I is 201, no, ma'am. So it will be greater than, I mean, less than 3 in the sense 2 point something. So it won't be an outlier there.
Okay, I value is 201. So won't it go beyond 3? 201 minus the mean value and divided by S.
No,
isn't
ma'am.
it the value going beyond 3? No?
No, ma'am, because 201 minus 36 would become something around 165. Divided by 62 would be less than 3 only, ma'am.
Is it? It is not treating 201 to be outlier?
In this case, no, ma'am.
Okay, then maybe the distribution. Okay, let me check the distribution of it. I should You have taken up the value. How do we look at the distribution?
Yes, ma'am, the value of zscore is coming 2.91 for 201. That means that is not considered 201 as outlier.
It is outlier, but since the distribution of the data is not following Gaussian, far from Gaussian, maybe because of that. Okay, let me change few of the values. Since the data is too small, I won't be able to see the proper distribution. Anyways, okay. So you need to have proper data here. Okay, now it is showing 201. There was no mistake in the code. The data wasn't proper. Data, since the data set was too small, might be it got little far away from the Gaussian distribution. Okay. So now since I have changed it, maybe it is little towards the Gaussian, and now when you find the z-score, it might be following the proper Gaussian. Now it shows the outlier to be 201. Okay. So you need to have some proper size of data with you with some proper distribution. Okay, fine. So now at least you have your algorithm has found the outlier, right? Fine, fine. Okay. Now let us see how to treat this particular outlier of 201. So these are the few methods. Either you can directly remove it, or you can replace with some meaningful values, or you can bound it, either floor it or cap it using quantile values. We are talking about here actually the 10th percentile and 90th percentile. These are three popular techniques. Okay? So trim or remove, so it is clear. But even before you try to trim or remove, you have to study your data well. Okay? Because the source of that outlier can be many. It might be because of the variability in your data set. It might be because of some experimental error. It might be because of some human error. If you are sure that it is because of some human error and can't be treated, you can remove it. But you have to be sure that it won't affect your data modeling harshly. So if that is the case, you can try and remove it. Suppose I need
one more.
Yes.
Hello.
Yes.
In previous example, to identify to detect the outliers. Hello.
Yes. Yes.
Yeah. Am I audible, ma'am?
Yes, yes, yes.
Yeah, ma'am. Actually, we had the number of observation were less than 30. So
Yeah,
formula we can use x minus mu by standard
yes,
deviation
yes,
divided by
yes,
square
yes.
root of n.
Yeah,
If you use that formula, you will get the outliers.
yes, yeah. That is one condition for this formula to be valid. At least the
We
least
should
number
have
of
30.
data value is 30. Anyhow,
30.
we don't have 30 values here. But the main condition is if somehow the data value is near to
Yes,
Gaussian,
ma'am.
you won't have the issue. Now, since we are dealing with code, let's actually see how to remove it. Any idea how to remove? How does Python help you to remove some values that you have?
Ma'am, using IQR lower bound, upper bound. First, we'll identify using percentile method. And
No, I'm
then
talking
we'll
about
find
this
the
trim. Suppose I wish to trim that value. How do I trim?
remove the outliers.
Ah. I straight away wish to remove that outlier. So what we can do is we can make a new array, right? Let's see if it works. We can delete it, right? We can delete that particular
Yes.
value from X, which satisfies this condition where X is, we have defined I already, right? Or else write straight away na 201. So you can straight away delete it. Now it's still somehow some issues are happening. Anyways, you have this option of deleting it. Or should I? What name? Outliers. I named it outliers. Oh, what again? For I in outliers, I have outlier value in this array, right? Outliers. For I in outliers, I'm forming one new array which will have all elements of X except those for which X is I. Huh? When X is I, it will delete. Return a new array with subarrays along an axis. Deleted for one of those entries not returned by array object. Yes, this one. Okay, this is again one task. Huh? Find it out. Let me know something. Next is your imputation, where you will either replace the value with mean or median for numeric and replace with mode if it is categorical. Okay. This one. So for this also, try on your own, try to write a piece of code where you will be able to replace the outlier value. Here in case 201 with mean, with median. Okay. Or else you can use mean since you won't be including 201 here. Okay. So you can try replacing that value and try to form one piece of code on your own. Since mine is encountering some issues. Okay. And the most used, the most popular one is this, flooring and capping the outlier values. Okay. Based on the percentile values. So, now flooring and capping the outliers means you will form a new array using the 10th percentile and the 90th percentile value. Your data should not cross the 90th percentile and your data should not be less than the 10th percentile value. How do you find percentiles? Suppose for our own data, if I need to calculate the 10th percentile.
And NP dot percentile.
NP dot you have straight, no?
Yes, ma'am.
Let me see, even if this, if I need to find 10, so you will have 10, right? 10 percentile,
Yes.
NP dot percentile x comma, and I hope to put 10th percentile. And what about the 90th percentile? Same, huh? Format is.
Yes, ma'am. Yes.
X, T. So this is your 10th and 90th percentile, okay? So whatever the values your array carries, those values will be floored and capped by these two values. You would have, let me try once more, okay? Let me, just excuse me for these codes which are not working. I don't know why. B equals B dot. I'm using the same right syntax, otherwise it would have shown an array, right? Sorry, error. X less than.
I wrote the simple, ma'am. It worked. Miss, I did not use the for loop. I used the simple that code and it worked.
You didn't use the method, you directly removed it?
Yes, ma'am.
Did you use?
Delete,
Where is the mistake? Tell me. Okay. Let me see one more. X, if it is less than 10th percentile, so it has to be bounded by the percentile value. Else it will have X. Okay. And again, You have to bound by the 90th percentile value here. So C should be your modified array.
Greater than, ma'am, I think.
Sorry. See, this is how you use the percentile values to make your data values bounded. Okay. So this way you won't have to remove your outlier. You will just transform the values. So using those percentile values, you are just transforming these data values that you have. This is another way to bound the outlier values and transform the data using the 10th and 90th percentiles. There is one more way. We actually have discussed this term before, interquartile range, if you remember. Just we will end our session with this one, okay? Let me just interquartile range. If your data value is outside this interquartile range, it will be treated as outliers, okay? So I hope you remember this figure. Just let me quickly go through it. Is this box plot, right? If your data is properly distributed and if you draw the box plot and look at all the 5-number summary, it will look like this, right? Which value appears here in this location?
Median.
It's median.
Percentile.
Median.
Percentile.
Median or 50th percentile. Huh? Here is
Q1.
25.
Q1, yes.
Quartile 1.
Yeah. And here is
Quartile 3.
Q3.
And which percentile is it?
75.
75, ma'am.
25th is this one.
Yes, ma'am.
25th percentile, this is 50th percentile, this is 75th percentile. Okay. This is quartile because it distributes whole range into 4 equal divisions. That is why it is quartile. Okay. If all the data is properly distributed, you will have 4 almost identical distribution. So here appears your minimum and
lower bound.
Lower bound,
upper bound.
Or mix. This one. Okay. Now, this distance from Q1 to Q3 is your IQR. Okay. This distance is interquartile range. Now, if your data value appears here, outside this and outside this, those will be your outliers. Okay. That means you have to find out the upper bound, you have to find out the lower bound, and then you will check through your data which values are outside these 2 bounds. Those are your outliers. Now, how do you define these max and mean with respect to IQR is you have a relation. This maximum bound is actually 3rd quartile plus this distance. This distance is 1.5 times the interquartile range. Okay. That is your relation. And this is Q1, this Q1 minus this distance, 1.5 times the interquartile range. So what you will do is you will find out this upper bound, you will find out this lower bound, you will look through your array, look for those values which are outside this bound. So this is another way of looking at the outliers. You can make your algorithm understand what outliers are in your data. And if you found it, then you can again use these methods to treat them. Okay. So these pretty much covers the techniques, okay, some popular techniques with the feature engineering, mostly with the outliers. Today's discussion wholly focuses on the treatment with the outliers. Okay. Now, transform meaning one hot coding also transforms the data, but in a different sense. So, in tomorrow's class, we will deal with the rest of the methods. Okay. And please, you carry out these things which I have left. Okay. If you find where the mistake is, do let me know. And you try to work on your own with this interquartile thing. Okay. Try to code it and see how it detects 201 in the data. Okay. Or you can make your own array and try. Look for the IQR value, find out the maximum and the minimum, means the upper and the lower bound. Look into your data, which are outside these bounds. Those are your outliers. We will again, I will again take these things with some real data set. We will work with them. Okay. So this is all about the treatment of the outliers. Fine.
Please, I have a question. Can I ask a question?
Yes, yes.
Is the same data set, or we can do our own thing? Is it compulsory we have to use the sets?
Can you please repeat?
I'm asking, is it, you said we are going to continue doing it. Are you going to give us a different data set for it? Or we are not going to, we have to write our own code for it?
Okay, somehow I am unable to hear what you are saying. Can you write?
I'm asking.
Ma'am, he is asking that shall you provide the data set to work out for, otherwise he will do his own data sets. He will work on his own data sets.
You can form your own data set. You can form your own data set.
Okay. When are we supposed to submit it?
Okay, you don't have to submit it. You just have to ping me and let me know what you did. Okay.
Okay. Okay. Thank you.
Basically, this is for the class practice. There is no submission. Sir will provide you the task which is required with the submission.
Yeah, submission thing is different.
Okay.
Any question regarding today's session? Anybody? No?
No.
Okay, let me stop the recording.